I'm very excited to be here hosting this Hangouts on Air to discuss the record Arctic sea ice decline that has occurred this year in 2012.
I'm Don Farmer. I was one of the ones that was chatting with you that got this started.
Graduate student in civil engineering and fluid mechanics at University of Illinois.
This is Martin Lewitt. I'm currently working for a biotech company, but I'm a member of the American Geophysical Union, and I've participated in the Working Group 1 reviews in AR4 and now in AR5.
There's been a lot of work trying to understand the cause of the increase in global mean temperature, and really that increase both for the global scale temperature and for the pattern of warming in the atmosphere and the ocean is not consistent with just noise, just variability in the climate system. It's not consistent with these other possible forcings, and it is consistent with increasing greenhouse gas concentration.
So I would like to know that what will be the long-term effect of these trends we are seeing at this point of time, especially on the ocean circulation.
Are there any predictions about what percentage of the ice that melts in the summer comes back in the winter?
Are we seeing any changes in global currents in the ocean now that are going into the Arctic and flushing it because of the returning ice?
It's really no question in terms of observations from satellites that this has been a very anomalous year relative to the variability in the late 20th century, and these low years have been very normal for the past 6 years or so.
Look forward to having another 30 years of climatology. I think 60 years is about where we should be.
I look forward to the next 30 years as well.
Is there any way to tell what might have been the ice extent in the last century before the satellite images came up?
But we haven't had satellites for very long, so we're just like beginning our observation, our direct observation. We've never had this opportunity before.
Right. So if we want to understand the longer-term variability, say the centennial scale variability or millennial scale variability, then a lot of that work is done using geologic records.
So what do you mean by a storm pushing it back? Is it like did the storm help to break down the ice which was floating even further, or how did it happen?
Well, so the satellites are measuring the extent of sea ice. They can also measure the thickness of the sea ice, and even the age of the sea ice can be calculated. And that sea ice extent is partly a function of temperature, temperature of the water, temperature of the sea ice, and it can also be sensitive to the ocean circulation and the wind, the atmospheric circulation.
There's a tendency in the industry to announce a new generation of models and assume that they've been born afresh without any of the previous things.
Well,
I think they need to prove they don't have this.
Okay, so you can look at Ray Dokanuti's work on the climate model genealogy, and that'll, whether there's a tendency in the community or not, that work is out there, published in geophysical research letters.
Is the edge of where the ice sheet is, does it affect weather? Like, are we going to see the jet stream move or change, or like what goes on there?
Yeah, so good question. Definitely an area of active research. A lot of recent papers on that question.
The community has been seeming to increase the weighting for black carbon. What is your take on that?
Black carbon will fall out of the atmosphere and land and continue to be dark on the snow and ice surface, and so there's a lot of evidence now that with the transport of black carbon in the atmosphere decreases the albedo of snow and ice surfaces and accelerates melting by increasing the absorption of the solar energy. Thank you all again for joining. I really enjoyed it, and we'll see you all next time.